everybody. Welcome to this episode of the Turing Boundaryless video. This is your host Alina and I'm tuning in from India. I'm a content specialist at Turing.com, and today on the panel we have a very special guest joining us from Moscow, Russia. Ivan heads the machine learning team at Turing and has more than 8 years of experience in the field of data science and the software industry. He's a machine learning enthusiast, and today he's here to share his thoughts on how we can use engineering systems that use AI under the hood. So first of all, Ivan, thanks a lot for joining us today. How are you doing? And I'd really like to know how your journey at Turing has been so far.
Hey, Alina, and hey, everyone. I'm definitely glad to be here. Thanks for having me. And I don't know if the answer right now should be short or the long one, but the short answer is, yeah, I'm fine. I'm doing great. And life in Turing so far was fun, challenging and exciting as expected.
Okay, that sounds interesting. And before we move forward, I'd really like to know more about you and how your journey has looked like in the machine learning field and the data science field. Could you tell us something more about that?
Okay, so speaking about my journey, let me start with the beginning, right? So right out of university, I don't know how it's about for others, but for me, I wasn't sure what I wanted to work on. And my first major was in economics, and it was not only in economics, it was mostly like math in economics. And what I did a lot as an economist, I explained outcomes. So let's say we have some inputs, we have some outcomes, and we try to map to find a way to find an explanation of like, if we change inputs somewhat, what would be the change in the outcomes? So that's like the first part. The second part is that I tried building some businesses here and there, and one of those was teaching applicants for universities, like people who are trying to enter universities, teaching them math. And like I created my own courses for that. And like, you know, there is a saying that goes like, I explain people things 3 times, and even I have started understanding this, but people still didn't understand this. But at least like I started understanding the things that I was explaining. So I started understanding some even more math. And then also, I don't know like how it's happening for others and when you have venture capital and stuff, but I did probably a wrong thing, and I tried to build everything from scratch, doing everything myself in my own businesses, myself, like me and my partners or friends who we work with. So I was mostly responsible for IT part of the whole thing. So I was building sites, I was building databases, I was building different IT systems around those. So then all those things basically come together, like the background in math, my I don't know if you can call it proficiency, but like it was, at least I was good in math in general. And also I liked this IT development and programming and stuff. And I started looking into data science, and I fell in love with it. And then like several years later, and here I am, right? So how the industry developed, like before and after I joined it. Okay, this will be highly opinionated, and sorry about that. But in my experience, like I think everyone knows that there is a lot of hype around data science and artificial intelligence and machine learning. So what happened is that at first everyone hired people who were called data scientists and considered this to be sort of like money button. Like you hire a data scientist and then everything becomes magically wonderful after that, rainbows and unicorns. And actually what happened is that people hired data scientists, and in some of the companies who knew what they were doing, some things happened. But in most of those companies who wanted to just join the hype and try to like incorporate data science in their practices, become data driven, it didn't work that well. Why was that, right? With that, in my opinion, was because usually companies are not yet prepared enough to start using data science when they actually start doing that. So what I mean by that, for data scientists to be valuable, you need to have a data infrastructure, and it takes a long time to build it. And in many companies all over the world, these kind of things were always not a core functionality of business, not a core thing for the business. So it was mostly outsourced. Like we have all those Oracles and SAPs and other companies who were specializing in specifically this thing, that they were handling all the things about IT part of things, and companies could focus on what they could do best, right? So in general, that and other smaller companies also, like in general, they didn't care that much about data at all, and about the practices of storing data and stuff like this. So mostly things happened in Excels and PowerPoints, as they usually do in business environment, right? So that's not an ideal environment for data scientists, because you need a lot of data and you need clean, good data. So companies in general were not very prepared for this. So that required having people with different skill set, what we can call data engineers, people who build this data infrastructure that gather different data from all the different places in one place in such a way that it can be worked on by other people and that it can create value, right? So I don't know, let me have share some example here. Like if you have, I don't know, 120 stores distributed all over the country, then, and each of those stores has some database that is not put in some particular place. Like when some accounting happens, it's happening in each of the stores, then the results are collected in some central hub where like the super duper high level accountants are crunching those numbers and getting the final result, right? That's at least what I have seen as a general paradigm. However, then the companies transition to a different paradigm where they can gather the data itself in one place and start analyzing that. And yeah, for that, you need data engineers, you need to build data infrastructure. Now what? Now we have data scientists and they can kind of work with this data. And let's say, I don't know, let's take some particular example here. So let's say we're trying to predict house prices, right? So we are, I don't know, some big company who works on this kind of market. You are trying to predict house prices and play on the, like, have a lot of capital and buy houses, sell houses, or maybe sell some advice. So we have gathered all the data about houses in some particular country in one place, and data scientists have built a model that says, okay, so if you put this house should cost this much, and this house should cost this much, given the current like market situation and what we know about those houses and stuff. Okay, if it seems that we are done here, then that's not true, because the model is just a part of it. So if we lived in a static world where we can just gather information about houses in one place and build one model, and that will be it, it would be great. However, that's obviously not the case, right? Market changes, market condition changes, houses get taken off from the market, they get put back to the market. So obviously you need to be able to update all those things at the same time. So what's actually happening is people are building, data engineers continue to build systems that instead of like doing all these things just once, gathering all the information together in one place, they do it constantly. And then data scientists should also be able to what we call retrain their models, right? So the new data should be incorporated and making those kind of decisions and like in improving the systems. And who are data scientists, right? They're scientists. They're not optimizing for writing some sustainable system. They're optimizing for finding a solution to the particular problem, which usually is like, okay, given the information about houses, what would be the best way to predict their prices, right? And what they're doing is they're testing different hypotheses. Okay, let's try to put the number of bedrooms in this way in the model. Let's try to incorporate, I don't know, the coloring of the floor and ceiling in the schema. And let's think, how can we incorporate information about garden in these predictions, right? So I don't know, their code can be expected to stay, to be needed for 12 minutes or something. And then after that, they just discard their code and try a new idea, right? And obviously, they're optimizing for that. And that creates a great mess of the final result. It obviously depends on the data scientists, but in general, they shouldn't be very concerned about this. They should be concerned about creating the best solution to their particular problem, right? However, when you create this model, then what, right? It should be making those predictions without manual intervention from data scientists or from whomever. And in the real world, there are a lot of edge cases. And to work with this situation, you need people with different skill sets. And those people are machine learning engineers, and the industry, it took some time for people to understand that, like, you cannot just tell data scientists that, okay, we have this problem, please be our money button, right? They also need to hire people like ML engineers who are building those scalable systems from the models of data scientists. And certainly there are people, people in data science who can do both things, but in general, it's different skill sets. So obviously it's harder to find such people. And actually, I'm one of those people who transitioned from strictly data science to deployment of the models. And now in Turing, I'm working mostly as a machine learning engineering manager, which means that basically me and my team were responsible for all those models that we're creating in Turing and that we're putting those models in production. So that's one part. But what's another part here, right? I said that we have those accountants, and those were like the sources of information previously, right? But let's say we got all of the information in one place. Why don't we have some person who can answer our questions like, okay, should we open a store in town N? Should we change our assortment to like this stuff, right? These are business decisions. And previously it was like, you know how those were done, right? There were some people who are like experts, who know the market, and they say, okay, I think I have a hunch that this is a good thing to have this. And that's how decisions were made. And obviously, some people can be right, and some people, there is some randomness in the whole situation. So that's where data-driven decisions come into play. And to make those data-driven decisions, you need this data to be sorted out and visualized in some way that helps you to do that, right? So here also data analysts come into play, but also different companies and different people come those special roles in different ways. So someone like data analyst in my understanding could be data scientist in some other understanding. So I'm not like the source of truth here. It's just like I'm defining the things as I go, right? So data analysts come into picture, and those are people responsible for crunching the data and visualizing it on the dashboard so that business can look at the dashboard and say, aha, so we need to change the assortment in this way, and then we change the assortment in this way, we did it wrongly and stuff. So yeah, that's like what can you say, not the final situation, because then, okay, you have built these systems, now you need to scale them, right? And usually it can be machine learning engineers who do that, but there are also like specific kinds of engineers that help with scaling those systems to a big number of big number of requests or something. Those are sometimes called ML ops people. But in general, that's the pipeline of the whole data science process. And that's the way the industry went from like being unable to get any value out of data they have to using all those people in a correct sequence to get the actual value in there. Yeah, sorry for being so long, but that's my perception about the industry.
Yeah, that was really great. You dissected the whole process and talked about how you move from data science to machine learning and how different the two fields are and yet related, right? Moving forward and, talking in detail about machine learning, will you also help us understand the difference between AI and machine learning, the two very related yet different terms? And of course, how does the future look like with AI and machine learning in the
Okay, sure. So, well, you know how the saying goes, when it's in PowerPoint, it's usually AI, and then it's in Python, it's usually machine learning. So let's start by defining what AI is. Artificial intelligence. Okay, we can talk about some general artificial intelligence, which is just like artificial brain, artificial thinking, as we people understand, right? And it's a whole different topic. It's a very complicated thing, and there are very clever and opinionated people who are thinking that this is a great thing or this is a highest threat to the humanity. I'm not sure where I am, and I'm not sure that I can add a lot to the debate. I'm mostly listening, and I definitely have my opinion, but let's not get into this right now. But there is also artificial intelligence in the less less strict sense. So what I'm saying is, artificial intelligence can be defined as a system that can make decisions that usually are made by people. So I don't know, vacuum cleaner, right? So usually you decide where you go with your vacuum cleaner and what part of the room do you want to clean. But this decision can be taken for you by the vacuum cleaner itself, right? So that's kind of the decision that can be made. Or for example, the Maps app, to take your favorite Maps app, right? It just creates a route from point A to point B, and people can definitely do that. But it's obviously like a complicated algorithm that takes a lot of things into account, definitely the distance, but also other things. And currently, like those are also things that can be considered artificial intelligence, right? So artificial intelligence is a general field of making decisions that could be taken by people, but also are currently taken by systems. So machine learning, I would call it a subset of artificial intelligence. Maybe maybe it's not just this subset in strict sense. There definitely are people who would argue that, but let's call it a subset of artificial intelligence, okay? And in machine learning, what you mostly care about, okay, when I talked about me being an economist, and I said that we have those inputs and outputs, right? And as economists, we mostly try to explain these things in terms of, okay, if we add one bedroom, how much does the price change, right? And machine learning specialists, they are concerned about the question, okay, we have this house that our model has never seen before. What would be the price of this house, right? So economists try to explain the outcomes, like bedrooms are more important than coloring on the ceiling, right? But machine learning specialists try to answer the question, like this house that was never seen by the model, how much is it? So the ideas of generalization to unseen instances, unseen observations, and you need to create a model that does a good job about that. So, for example, let's talk about Turing for a moment. What is the most important problem that Turing solves, right? There are people who are looking for employees, and there are people who are looking for employers. Obviously, there could be a match, but we all know that it takes for both parties a lot of time to find a suitable match for some particular role. But usually, the problem here is lacking some information from both sides, right? So you don't know how good the person is, so you need to ask many questions. And from the person's perspective, you need to prepare and do a lot of different stuff. You know, the thing, right? So what we are doing in Turing, we know a lot of information about companies. We know a lot of information about people, but we also know where we got good matches. So we have a history of matches, and we know like these people were great for these companies who have these requirements, and we know skills of the people who were great matches. So we can go through that information, and what we can generalize for is like we have this new job, we have these new developers that our model has never seen before, but would those two be a good match or not? And then we can, for each of the companies, we can show like, okay, you have this job, we understand your requirements. These are the people that are probably the most relevant for you in the descending order, right? So then customers can like choose developers they want to interview and go on with our processes. But in general, that's the problem we want to solve, right? So getting back to the question, machine learning is a part of artificial intelligence that tries to generalize some function between inputs and outputs. And we are using it in Turing. It can be used in many different places. But getting to my previous answer to the previous question, a lot of companies are not doing a good job. I don't know. Let me put it differently. A lot of companies don't understand the whole process. Like I have mentioned 4 or 5 roles, different roles who work in machine learning, and those people have different skill sets. Definitely there can be overlapping, but you probably need to have all those people. And you also need some manager who understands that you need all those kinds of people to achieve great results. Or you will be looking like for some super developer who has all those skills at the same time, and those definitely exist, but it's harder to find those. And usually those are already the managers who understand who you need to have, right? So that's one part of the process. And another thing is that managers in general don't usually understand what's happening under the hood, right? They just want like, okay, let's do machine learning. And let's do machine learning doesn't mean much if you don't understand what you are exactly trying to do. In Turing, for example, we exactly understand what the problem is, right? We have information about the market that both parties might not have. And we are using this information to help them find each other, to help them have a great match, right? But for some other companies, they might try to do some things that are not, where machine learning is not applicable. Let's put it this way. Yeah, so that's the general outline of artificial intelligence, machine learning, how we use it, how other companies use that, when it helps, when it doesn't.
Very interesting, Ivan. And now I am very curious to know know more about building programs with AI and ML, right? So can you tell us more about the process and, of course, how AI and ML help make systems easier?
Okay, so let me start with the last part of the question. Does it make building systems easier? I don't feel that's the case in general, because when you're building software system, it's already quite complicated. You need to think about all those corner cases and stuff, but at least we can separate different parts. Like there are good practices where you separate the state from the system itself, and there is a database for storing the state. There is a system that is kind of stateless, and everything is working fine. But then machine learning comes into the picture, and it doesn't work this way. It works. It has more degrees of freedom, right? Because your inputs might change, your outputs might need to change, your model should be retrained, and your model can also change, and there can be bugs in your pipelines anywhere. And in general, those systems have more degrees of freedom, which makes them harder to manage, obviously. So we cannot do anything about that. And the only reason why we are using machine learning is because it helps us to do things that were previously not possible to do, right? So let's take Turing as an example, right? We definitely also have people who help matching the same people to the jobs, right? That's what we started with. Currently, our algorithms work together with people to improve the process. However, let's say we scale to a bigger market, right? So currently, I don't know how many people, how many matches can you try to find in some short amount of time? What if company needs to hire like 50 people? What if 100 people? It's very hard to scale if you're not using some machine learning system to help you make decisions or even to make decisions for you. So that's the only reason why we are actually using, why companies all over the world using machine learning. It doesn't make things easier, it just makes things possible. Okay, so did I answer your question, or was there some other part that I have forgotten about?
Yes, I think there was this one other part about building programs using AI and ML. And you could tell us more about the process.
Okay, so in general, the process kind of goes like what I was talking about when I was talking about the whole industry, right? So usually it goes like this. You have some data engineers, they build some data infrastructure, and then there are data scientists who can play with different data to achieve some particular goal. Let's say you have information about jobs and applicants, or information about houses and their prices. And the more information you have is generally the better. The better quality of information is obviously usually the better. Data scientists are trying to create a model, and what they are usually doing, they're usually doing the obvious thing. They're like hiding some part of the observations from the model, and then they are like training the model on the other part of observations, and then they try to predict for this like hidden part. Okay, so we know for those houses the prices will be this. What do you model predict? And the model tells them, okay, these are the prices, and they measure how good the predictions are, and we have different metrics for that. And for Turing, obviously, we also like we know that these two parties were matched. So do you model think that there is a high probability of match here or not? And we can check, the data scientists can check if the model is correct or not. Then machine learning engineering comes into interview, and machine learning engineers are trying to build a system that takes the same data as data scientists used and takes their models and combines those together in such a way that it can be like changed in the future and can be scalable and can work fine in production, because all those things are not simple. We need to like this becomes a software system, right? So what is a software system? Software system is, for example, the code will probably work for a long time, right? When previously I said data scientists are writing code that will probably be discarded in 12 minutes, they're definitely not optimizing for the quality of their code, and they should. However, machine learning engineers should optimize for the quality of the code, should optimize for the quality of the system, should make it scalable so that we can change parameters easily and the latency would be good and stuff. That's what we actually are working on in Turing on right now. And then there is the next part, the important part, that the whole infrastructure for machine learning should be built in such a way that the whole process of adding new features to the model should be fast. And we should get the results like, let's say it's 1 month, right? Then we have, I don't know what, 12 iterations a year. And that definitely slows us down, right? But what if one iteration is 1 week? then we can do 52 iterations in a year. And definitely by the end of the year, the company who can do 52 iterations should probably be ahead of the companies who can do just 12 iterations. So that's the main, the overarching goal of machine learning engineering team and all infrastructure that we are building. And that's like a meta level of what data science process is about. The first level is building this system, like getting data, training model, putting that in production. But then retraining, rebuilding, adding new features, and iterating over this is the next part. That is even more complicated than just building the model. And then we can also like introduce different new things here. Like, for example, we can retrain the models automatically. And then we also need to add additional layers of that ensure us that we are doing the right thing, putting this newly trained model to production when the whole thing is automated and stuff. So yeah, these are the general parts of the data science work.
Okay, that sounds very interesting, and thank you for explaining that in so much detail. Now, moving forward, I would like to talk to you about the about the considerations that we need to build a robust AI and ML infrastructure. What do you think is the secret sauce for a successful AI?
Well, from my understanding, and it mirrors what I have said before, I think that the most important thing would be management, who understands what they're trying to do with machine learning and why they're trying to use machine learning, because machine learning is just a tool. You can always achieve the same purpose with using different tools, and machine learning, like from people who have experience, they can actually have good predictions about where machine learning would work and where it wouldn't work for which kind of problems. So the machine learning, the management who understands the whole thing is the first step. And probably like, it would be good to also understand the meta level that I have just been talking about, right? That we need to build infrastructure, but that's kind of common sense. But there are so many nitty-gritty details that it's important that people have some hands-on experience with that, in my opinion, at least. Then, if we have such management, that solves a lot of other problems that I have mentioned that companies have, right? So usually it's a big digital transformation. Everyone loves these buzzwords, but that's actually what we call digital transformation, when you stop perceiving all things related to IT as just an unimportant part of what your company is doing, and start thinking about this as a core company functionality, core company thing, right? And this obviously requires a lot of investment. This changes a lot of the processes. Companies are working very differently after that, after what we call the digital transformation. I don't see it might be just me, but I don't see how it can happen without leadership from the management. And then, if this leadership is good and if managers understand what they are doing, they will probably hire all those different kinds of people who know also what they are doing, and the whole data science system can be built in the way that I have described. And it's not like there is just one good way to build machine learning system, but there is obviously good and bad ways to build it, and probably we need good managers to choose the good instead of bad ones. Yeah, so that's the secret sauce. I don't know how much secret is that you need to hire great people to achieve great results, but yeah, couldn't come up with anything better.
I think that's pretty much the basic underlying factor for every hiring process, and it probably works this way for all teams.
Yep, I couldn't agree more.
Yeah. Now, when we speak of building engineering systems with AI under the hood, I know you've mentioned this quite a few times during our conversation. Could you give us some examples of any such engineering systems that you're building at Turing?
Sure. So yeah, I have already mentioned the core functionality of Turing that matches developers to employers. That's obvious one. But under the hood here, there are also a lot of different things that we are building. So I don't know. This is just like a front-end functionality, right? But what's happening behind the scenes? For example, let's say we have developers, and obviously some developers are available, some developers are not available. Some developers are motivated, some developers are not motivated. Can we gather this information about developers? Can we understand which developers are will be able to will want to go and be able to pass interview for this particular company? These are the things that are like subsystems in Turing. For example, we can try to predict developer availability. Then we can use that, like, okay, given this super cool developer who has 0.7 probability of coming to an interview, and we compare him to this not that cool but still cool developer who has like 0.9 probability of coming to an interview, who should we choose? And eventually, like in the long term, we definitely know the answer to this question because we will have enough data to know, like, for this company we should prefer this developer, for this company we should prefer this developer. But in general, this prediction of availability is one of the things that we are working on. Another thing is obviously like we are using some deep learning techniques to try and understand the how could you put it? So let's say we can put developer in some place in space. So abstractly, let's say one developer is here and another developer is here, right? So then we can also do the same thing for jobs and say that this job is here, okay, right? So we have these two developers and this one job. So this developer is closer to this job. And this like intuitive meaning of this thing is exactly what we are looking for. We try to find like where developers can be put in some high dimensional space of different like skills and put the jobs in the same space and find like what are the good combination of those. And it can also inform our models in terms of like which developers should we choose for which roles. What else? We also are working on different other parameters that can be taken into the model, like feedback features that show us like, let's not show the top developers who are not hired constantly. We are working on the general improvements of our architecture because we're currently scaling very fast and we need to somewhat change how our systems are working, and we have now much more people in Turing. So we can have different teams working on different parts of the system. Painful growth process, right? But that's what we're going through, and I think we're doing it well enough right now. Yeah, so those are some of the things that we're working on right now.
That looks very, very interesting. And I hope that after watching this video, a lot of the developers would be interested in joining Turing as well. So if you have like 3+ years of experience and you're confident in your skill sets, please head on to turing.com/jobs and apply now.
Sure, please do that.
Yeah. Now, Ivan, I know that you've talked about how machine learning has evolved over the years, ever since you started working, right? What do you think is the outlook for machine learning in the years to come?
Well, there is kind of a short and maybe common sense / obvious answer to that, which is it seems that artificial intelligence and machine learning can do more and more things as time goes on. And all the trends points in the direction of it becoming even more powerful and used even more throughout the industry. Because currently, like obviously, Silicon Valley startups and IT companies, they already incorporate machine learning in their day-to-day jobs, day-to-day functionality, and they have been doing that for some time already. But other companies that I have already mentioned that are not considering IT as the part of their core functionality, they're just starting or maybe like going through this transformation process. And in the future, we should expect more companies to be using data science in some way. But there is also, yeah, that was like 1 minute short answer. But we can also have a long and maybe philosophical answer, because where is this all going, right? So it seems, and this is debatable, but it seems that machine learning can actually get a lot of people out of their jobs. But what is important here is that it's still creating the same value and maybe even more value than people did, right? So in terms of the economics system and society, the same value is created, but people are spending less and less time doing that. And then the societal level question would be, how do we use this additional value? How do we distribute it? Because the older systems, older paradigm of like working to get your paycheck seems like it will be deprecated if we have, I don't know how many, like 10, 30% of people out of work. It's still debatable if this happens, right? I'm definitely not saying that it definitely will, but if it happens, and there are trends that are showing in this direction, right? So what will happen to the society at large? And I don't know the answer to that question, but I hope that like we can make some good decisions. There would be good leadership there, and maybe we can achieve some result where people who don't want to work don't have to work. And there are such people, I know such people. And obviously people who still want to work can also find something for them. But it's hard to predict in this kind of environment. And let's not even start with general artificial intelligence, because that's a very interesting topic. I don't know if you have heard about like what is thought about as singularity, like when we get to the level of artificial general intelligence, and there is this concept of it learning constantly and becoming and improving itself constantly, and becoming much better than people fast, and then we cannot control it, and then it has some function to optimize for, and if it optimizes for something that is not wanted by people, then we are kind of doomed. But there are also a lot of people who are saying that all the things that we are doing are not even close to this, and that it should never happen and stuff like this. But yeah, I don't know what to say here. But this is an interesting outline of our future, definitely. So yeah, these are my like three-step answer to this question.
That definitely looks interesting, whether or not AI takes over the world. But this definitely is like an interesting outlook of where machine learning and AI looks like in the years to come. And this was a very interesting and a very amazing discussion. I had a lot of fun talking to you. And as we close this discussion and we wind it up, could you like share one final piece of advice for engineering leaders who are managing distributed teams for the first time? How should they go about it?
Well, I think for a long time, in the industry, I have said the word industry for so many times during this interview, but yeah, still, the industry and maybe the whole like society was going in the direction of less controlling management. Like there was this industrial idea of people working on conveyors, and they just were repeatedly doing the same task again and again and again. And currently, there are more and more people who are working in some creative jobs that actually require thinking. And as far as my understanding of the current literature goes, is that in this kind of environment, people are not performing well if they're working more than particular number of hours. And also people have their specific schedules, and the more you can, the more you think about what works good for them, the better their outcomes, and outcomes of your company would be. So what I'm saying is basically that the older paradigm of controlling is being substituted by the paradigm of trust, because how can you control really people working from their homes, right? You cannot just turn on Zoom and look at them for the whole day, for the whole working day. And people are definitely doing their own things in their work time, but they are also working outside their work time, and the concept of work time become blurry enough. So eventually, I guess we are going in the direction of thinking about assessing people by their results instead of by the number of hours they spend and stuff. And obviously, we understand that that's a better way for people who are actually delivering some work. But from my perspective, it was hard for me to just let some things go, to not try to micromanage at all. In stressful situation, I was still falling back sometimes to this approach of, okay, tell me what you're working on, tell me when you're going to finish this, why didn't you finish this, this kind of stuff, right? This emotional turmoil kind of thing. But eventually I kind of changed the way we are working as a team commitment. And it's still we still have a work to do on how can we improve things. But in general, I trust people to do what is expected of them. And in general, they're actually trying to do, and they're very motivated. That's what I see. So trust is better than control in this environment. That would be my advice here.
I definitely agree with the last line where you mentioned that trust is better than control. And I think this is where we are headed in the remote world, and this is how we are going to work in the future as well. And thank you so much, Ivan. Yeah, and thank you so much, Ivan, for sharing such valuable pieces of advice with us, for staying with us today, and for talking in such detail about machine learning and AI. It was really interesting for me to talk to you, and I had a lot of fun. I hope our audience found this really helpful too. Thank you so much, and I hope to see you again.
Thank you, Alina. It was my pleasure, and yeah, I hope that what I was saying would be interesting to someone.